Welcome to this session of rapid prototyping. In this session, we will discuss a process called extrusion mold based process, and we will be going to discuss fuse deposition model. Now, what do you mean by extrusion? Do you remember the word extrusion? Extrusion is a process of forcing a material out of a small area. So in extrusion based rapid prototyping system, there is a process called fuse deposition modeling. This is extensively used in industry due to its low cost as personal prototyping machines, which can be used for producing non-functional prototypes, and sometimes we can use it for producing some decorative pieces also. But in industry, there are high quality machines available which can use for producing some high quality prototypes. Now, let us see what this fuse deposition modeling is. The fuse deposition modeling, this technology was first developed by Scott Tramp in 1988, and the patent was given to him in 1992. The Stratasys Incorporation. This is the biggest manufacturer or a leading manufacturer of FDM processes. They also produce some other products also, but FDM is mainly they are big contributors in FDM technology that we can say. So this company was founded in 1989 and developed most of the company's product based on FDM itself. They introduced their first rapid prototyping machine, the 3D modeler, in 1992. Now, how this FDM process works? So, there will be a material in a filament or in a spool, and this filament will be melted in a specially designed head, and then it will be extruded on the models. So, when the material is coming out of the this head at this extruder, it will be in a semi-liquid form. So it will not be entirely liquid, but it will be a very thick liquid. So this will be extruded and it is cooled and solidifies to form the model. Now the model will be built layer by layer, same as other rapid prototyping systems. And when we talk about FDM, there are many parameters which affect the performance and functionalities, such as column strength of material, fracture modulus, viscosity, positional accuracy, speed, volumetric flow, tip rate, tip diameter, envelope temperature. There are many parameters which affects the process. This is the FDM machine. So how the process works? So this is the filament that we are talking about. So from this roll of filament, this filament will go into this extruder. This is the extruder head. So here it will be melted and it will be forced downwards, and here will be a nozzle, and from this nozzle you can print the part layer by layer. If you want to visualize the process, this is the part building process of FDM. We are adding layer by layer material. So there is hollow section between, and we can produce the bar layer by layer. This is obviously a time lapse image. So the FDM process itself will not be this much faster. This is a very slow process, but this is fast forwarded to just to visualize you how the process works. Now, how the FDM works. This is the schematic type arrangement of FDM, where the filament will be filled into extruder. This entire arrangement is extruder. So there will be this extruder, then there will be this temperature heater. So this temperature here will be controlled at around 220 degrees Celsius. Most of the time it will be from 180 to 220 or 250 degrees Celsius. And the melted part will come out from the nozzle. As this gets melted, the filament extruder will feed the filament, and the filament will itself force the liquid from the nozzle. And the part can be built layer by layer. You can build this layer by layer. Liquid you can add this layer, and this will start to cool as it comes into atmosphere, and as it is cooling you can get the new layers of solid. As once this layer is completed, the bed will move downwards or your filament will move upward. That depends on the machine, and then we can start building the new layer. Which materials will be used in FDM? So there are mainly three materials, polymer based materials. One is ABS, that is acrylonitride, butadiene, styrene. This is most commonly used material in the FDM, and this is industry standard. For high strength, we can use polycarbonate, which is also extensively used in industry in many parts. So we can build functional parts with ABS and polycarbonates, and we can also use PLA, that is polylactic acid. So these are the materials. These are the most common materials for the FDM. We can use many other materials also. But there are many materials developed for special applications also. But these are the most common used materials. Now, if we compare different materials, so this is ABS, this is ABSI, which is a form of ABS. This is ABS plus, which is again some extension of ABS, and the ABS PC is mixture of ABS and polycarbonate, and their properties is given. You do not need to worry about it. I have just given it for your understanding only. Now, what are different advantages of FDM? So we can produce functional parts with FDM of polymers of plastics, which is advantage. We can produce the part of same quality as we can produce with injection molding or other plastic forming techniques. So this is an advantage. We will not have same strength, but we can achieve up to 80% strength. The wastage is minimal of material. The support can be easily removed. There are two systems for support removal. One is brake uh, technique, and the other one is melting. So in both the water melt is another technique. In both the case, we can easily remove the support, and we can easily change the material. So for the same machine, you can use PLA also, and you can use ABS also, which is not very common for rapid prototyping techniques, because in most of the machines, if you are using a rapid prototyping technique, rapid prototyping machine, if you want to make a change of material, you will do it only by making large modifications in the machine, which is not the case with FDM. We can easily change the material. What are the disadvantages? The biggest disadvantage is the accuracy of FDM process. FDM is comparatively less accurate, so this is the biggest disadvantage. Also, the process is slow. So for even a moderate size part, the machine will take around 40 or 50 hours to build, and the shrinkage is not predictable. So there will be distortions and breakage of parts if your part is big. So these are disadvantages of FDM. Now where we can use FDM? So mostly FDM is used for conceptualization and presentation only. Sometimes it is used for design analysis and functional testing, and people have used FDM for patterns and masters. The masters is basically molds for different toolings. So this is where we can use the FDM process. Now I have some case studies of use of FDM. So this Toyota company used FDM. So Toyota is car manufacturer and TTL it is Toyota Design Center. So it is its design center. TTL is Toyota's design center. So design center they were developing a new model, and to manufacture fully functional prototype they needed around 10,000 to 1 lakh dollars for a prototype of injection mold. And this prototype of injection mold took 16 weeks to produce, where with FDM they produced it uh, in very less time, in only 2 days, and it's potentially saved about 2 million in prototype tooling by using FDM. From conventional to FDM, if they move from conventional to FDM, then they have saved around 2 million rupees in just prototype tooling cost. So here also the use of FDM have proven beneficial for Toyota. The another company, JP Patents, they also used FDM, and they used it for creating an invested cast waste pattern. So they created injection mold using FDM, and then from that mold they have created wax patterns, and from that wax pattern they have created the actual parts. So this is it for this FDM. If you have any doubts, you can contact me. Till then, happy learning.